Welcome, this is a Edexcel A2 C4 January 2006 past paper. This is question number 1. There's only one part to this question. It's just simply asking us to differentiate this curve. Oh, sorry. Well, we have to differentiate this curve. Sorry, just completely missed out the question. It's because I don't have the... Oh, the exam just popped up on my screen. Yeah, so we're given that a curve is defined by this equation, and find the equation of a tangent to the curve at the point where 1 minus 2, or in other words, where x equals 1 and y equals minus 2. Okay, let's find the tangent at that point in the form, not in the form y equals mx plus c, the long-winded one where you'll point on one side of the, just like this, but sort of the gradient function, but it looks like that. I could have just said it, but never mind. So it actually recalls you, asks you to recall some of your C1 knowledge. In this, the first thing we need to understand is, well, what's a tangent? A tangent is just the sort of a straight line that's parallel to the curve, so it has the same gradient as a curve at that point. Now, we can't just, because we've got x and y's in here, and well, we're in C4, it's not going to be as simple as it is in C1. We're going to be using some implicit differentiation, but actually, as we go through this, we're going to find it's a little bit more than that. Okay, so the first term is just simple, it's actually a C1, it's just 3x squared just becomes 6x. And then this 4y squared, when we differentiate 4y squared, we do the differential thing as normal, so it becomes 8y, but then we put dy dx next to it. And I explained that through the in one of my C4 tutorials on implicit differentiation. Basically, that's just come through using the chain rule as a way of differentiating y, because you can only as I said, that's all in that video, but I'm assuming that is very simple to you. Okay, so, and that's take 2, because obviously 2x becomes 2. Now, this 6xy does not become 6x or 6y. We've got, essentially we've got here is 6x times y. And now, okay, so that's what we assume it to be. Now, the only rule that we have, because obviously it's got to be a rule to do with differentiation, is that's what we're trying to do here. The only rule that we have that uses two products, they're not necessarily two products of x, they're just two products. We just say two products of x when we're looking at, well, say now, when we're looking at the product rule, because that's what we're going to use to differentiate that, because it is a product. Might not be necessarily a product of two x's, but it's a product of an x and a product of y. Now, we just said an x because two products of x when we describe that, because generally we'll only really see that when you just out and out using the product rule. You'll only use it with you know, two x's or two y's. You will never, when it straight asks you to do it, you would never get something that is as easy as that. It's more going to be something where you've got something like this. Okay, so what I would do is I would leave this, put like a little dot here, and sort of put a little page break in somewhere if you want to, and then write 6xy somewhere else on your page, and then from that draw, like what personally I do is I'd set a little bit aside. So u would be 6x, so therefore u dashed is equal to 6. V is equal to y, so therefore v dashed is equal. Now you could put 1, but don't forget the dy dx. So you could either write 1 dy dx or just dy dx. It's up to you. I write 1 dy dx, so you know it is you know, an answer, because y doesn't differentiate to become 0. Remember. Okay, and then it's just a case of using the basic products rule differentiation that you will have come across when learning. And in this, so it's a bit of a C3 if I'm right in saying. So anyway, what you do is it's VU dashed plus UV dashed, or the other way around, doesn't really matter. Okay, so I'll do UV dashed to start, so 6x times 1 dy dx. Okay, and you add that to y times 6. Now this is why I hate questions like this, because when you differentiate a y, you put dy dx next to it, and then whenever you see a differential that gives you an answer something y, then you assume to put dy dx next to it. But it's key to remember where your dy dx has come from. You've not differentiated y in the second half of the equation. You've just differentiated x. So you don't need to put dy dx on the second half where you add 6y. That's the bit that always gets me, but you know, I could be just talking a load of gibberish. So it's 6x times 1 dy dx, so you just write 6x dy dx plus 6y. Okay? And then you just sub this answer in to the last to continue in that. So where you would have put the dots, you could just put plus 6x. Now it's key in bracket. Now it's key not necessarily for this question in particular, but you could get questions like this where it's not add 6y, it could be take 6y. So what I'd always do is write in brackets. So you've differentiated 6xy, yes, that's very good, but you're adding the differential of 6xy. So you bracket it off. So in the case you do bracket 6x dy dx plus 6y. That's because if you were taking it away, you could easily spot the double negative, but it's very easy to see why people would go wrong on that. But it doesn't matter so much for this question, because it's nice just in adding the differential of 6xy to the other parts of the differential equation. But as I said, you know, it doesn't really matter for this question, but in some questions you may get where it's not as nice as this. Okay, and then it's just a case of rearranging it. So simplifying it down. I probably made this a lot more difficult because I'm probably going to have to rub some stuff off now, actually. So are you? I was going to say, are you okay with this? Me rubbing this off, and I forget there's no one actually sat behind the camera. So I'm just going to hope that you understand where we've got the differential of this from, and kind of rub it off. Kind of, I'm going to. Okay, so hopefully you've got that little bit here. As I said, you can always just skip back a few seconds if you didn't quite get all of it. Or if you can't be bothered, you know, just leave it. Okay, so the next step I do therefore is simplify it down. So you may not have wrote brackets around this bit, and if you didn't, I'm just going to be writing out again. Okay, so 6x plus 8y dy dx. Take 2 plus 6x dy dx plus 6y equals 0. Because remember, the minus 5 differentiated just to become 0. Okay, now, for the next step, I'm just going to kind of give you a bit of a refresher of implicit differentiation as I'm going through this question, even though I'm fairly sure some of you already know it. Well, some of you, hopefully all. But remember, this dy dx is not a notation, it's not like 8y with respect to dy of dx. It's not that, it's because we got this from the chain rule, it's 8y times dy dx. So the first thing I would do, that's kind of a hint for later, is put all the things that don't have a dy dx next to it on the right hand side, and all the things that do on the left hand side, or whichever way you feel, whichever way you can be bothered really. Okay, so I'm going to put dy dx on the left hand side because they're all positive, why not? So 8y dy dx. Now you may skip out this step here, and I'll explain why you might know it, but I don't want to skip a step and people go, oh, for God's sake, where the hell has he got that from? So no, just moving all of them across. So you add 2, you take 6x, and you take 6y from both sides. Alright, so the next thing we would do, that's why occasionally you can kind of skip the step out. Now, because this is 8y times dy dx and 6x times dy dx, if this was 8yx and this was 6yx or whatever, you would take out one of them as a common factor, okay? We take out dy dx as a common factor purely because we want dy dx to be the subject, obviously. Because whenever you see a differential equation, it's got dy dx next to it as a subject, sorry. So it's dy dx, and then you take out the 8y and the 6x. You take out dy dx as a common factor, so 2 takes 6x, takes 6y, okay? And then because that is dy dx times 8y plus 6x, you just divide both sides by 8y plus 6x. Now you could, you know, do your little division sign where you just draw a line under it and write 8y plus 6x, but that's just a waste of time and multiply, I can't be bothered. Okay, so dy dx equals 2 take 6x, take 6y over 8y plus 6x. Okay, now you could have put 2 plus 6x plus 6y over negative 8y take 6x, depending on which way you would have moved them across. But if you were to put, you know, x to be 1 and y to be minus 2, you would get the same answer, whichever equation you did, okay? So obviously the next thing we're going to do, as you do in any differentiation equation, is sub in what you know. So we know what x and y is, so 2 takes 6 times, and I would bracket this off, so remember x is 1 and y is minus 2, okay? And that's over 8 times minus 2 plus 6 times 1, okay? And if you would sub that in your calculator, you should get an answer of 8 over negative 10 or negative 8 tenths. Now I wouldn't write negative 0.8 because obviously it's very hard to sub in 0.8 because we've got to come up with the equation for a tangent, and generally when you see equations of tangents and normals and equations of curves, they don't really have 0.8x plus 2, do they? Obviously unless you do graph through Excel, you don't really get that, and obviously that's purely because we like to keep things simple in maths, because it's very easy to get complicated. That's why I'm very good at complicating stuff, because it didn't take much effort to do that. Anyway, see how much I complicated you there? Just a bit of a guide there. So anyway, that's our gradient, okay? There are our points. So what we've got now, this is like any other C1 question really. You write down what you've got. So you've got x is equal 1. We've got y to be minus 2. We've got the gradient m to be negative 8 over 10. Now keep in mind it wants it in the form ax plus by plus c equals 0. Now obviously they might not all be negative, they might not all be positive. So it doesn't, you know, it's got to be, basically what it's saying is it wants all the x's, all the y's and all the normal powers on one side, okay? So standard, it's a straight line, so y take y1 equals m brackets x take x1, because it's going to be a straight line, it's got a constant gradient obviously, but I don't need to tell you that because you already knew that. Y take y1, so it's y take minus 2, so you might want to double negative this off, or anyway it's just y plus 2 because you're taking away a negative 2, because y take y1 is the same as y take minus 2, because essentially y1 is minus 2, so therefore you add 2, okay, and that's equal to m, which is negative 8 over 10, which obviously you can tell what we're going to do. X take 1, because x1 is 1, times both sides by 10, so that obviously gets rid of the fraction, because we like fractions, but we prefer them to be whole numbers. So 10y plus 20, yep, equals negative 8 brackets x take 1. So just make sure I'm doing right, yeah, I've been completely gone insane. So therefore you just expand this out, so 10y plus 20 is equal to negative 8x plus 8. Now it's up to you which way you finalise this. As I said, you'll get the marks either way. You could move the negative 8x and the 8 to the other side, or you could move the 10y and 20 to the other side. Either way you would get the same overall answer if you put I mean, obviously it may look different, but you would get the same answer if you put x and y in there. So obviously you can't leave it as that either way. So what I'm going to do is move the 8x and the 8 over to the other side. In other words, I'm going to add 8x, 10 take 8 from both sides. So that'd be 8x plus 10y. And now it's 20 take 8, which is obviously plus 12 equals 0. And therefore that is your final answer. Okay, just let me make sure I've done that right. Well, I'm fairly sure I have, but so let me just double check the answers for you. You know, it's not so good when the guy who's going to be knowing what he's doing doesn't. Yep, that's correct. Now, I put 8x plus 10y plus 12. The mark scheme says 5y plus 4x plus 6. So that's just dividing all of that by 2. As I said, it doesn't matter. You can leave it as that. You will still get the full marks for that. Okay. So as it said, to give 5y plus 4x plus 6 equals 0, or equivalent equals 0. And that's equivalent to your 5y plus 4x plus 6. So if you got that answer, but you're looking on the mark scheme and it says what I've just said, and you're thinking, I haven't got the same thing, that's not right, well, don't worry, it is the same thing, because it is equivalent, although, you know, if you can simplify it, they would like to simplify it, but, you know, I mean, you've done the hard part. As long as you get this bit, it doesn't really matter whether you got 8x plus 10y plus 12 or 5y plus 4x plus 6. They mean the same thing, okay? Now, you know, as I said, if you had moved the 10y and the 20 to the other side instead of done what I've done, then you would have got negative 8x, take 10y, and then you would have taken 20 away from the positive 8, which would get you negative 12. So just to reiterate, it's negative 8x, negative 10y, take 12, okay? So really it's just moving all that onto the other side. Okay, so either way you would get the same answer. Alright, so thanks for watching. Hopefully it's been of some help, and we'll see you in the next video, which will be question 2.